Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 18 from the May-June 2019 Edexcel IGCSE paper 4 or paper 2H. This is from the 4MA1 syllabus, and this question here is about this cuboid, which has dimensions x, and 12 minus 3x, all in centimeters, and its total surface area is given by the letter A in centimeters squared, and we got to find the maximum value of A. Alright, so now what we need to do here is first of all get an expression for the total surface area of this cuboid. So the surface area of this cuboid is made up of the area of each of its faces. It has 6 faces. 2 of the faces, which is like the base here and the top here, they both have dimensions x by x. So those two together will have area of x squared and x squared. So you're going to have the surface area is equal to 2x squared. That's the top and the bottom. And then you have these 4 lateral faces, these 4 faces, which have dimensions x by 12 minus 3x. That's x times 12 minus 3x. So that's the area of this rectangle. On this side you have x times 12 minus 3x. So there's 4 of them. So you have plus 4 times x times 12 minus 3x. So 4 times x times 12 minus 3x. That will give you the total surface area of this cuboid. Okay, so if we expand this, we're going to get the area is equal to 2x squared plus 4x times 12 is 48x, and then you got 4x times minus 3x is minus 12x squared. So here we have a couple of like terms. We have 2x squared and minus 12x squared, so we have the area is equal to 48x minus 10x squared. So that is an expression in terms of x for the surface area of this cuboid. Okay, so we want to find the maximum value of the area. Okay, so as the value of x changes, the value of the surface area will also change. In fact, this is actually a graph that looks something. If we were to draw the graph of this A against x, we would see that we have something that looks like this. It's a quadratic. Okay, it's a quadratic graph, and it will go through the origin. When if this is the area, this is A and this is x, when x is 0, A will be 0. Okay, so it's going to go through the origin, and it's a quadratic with a negative in front of the x squared term. So it's a frowny face. It will have a maximum value for A. Okay, so it's going to have this type of shape. Okay, something like this. It will look like a quadratic, and it's going to reach at some point a maximum value at the place where it turns. Now there's a number of ways we could work out that maximum value of A. There's a few different ways that we could work that out. We want to find what the maximum value of the area is, and it's going to be when x is a value somewhere over here. Okay, when x is this value over here, okay, this is going to cause the area to be a maximum where it reaches its turning point. So there's a number of ways that we can work out the maximum value of A, and I'm going to show you 2 ways. One is I'm going to show you by what's called differentiation. Differentiation is when you find the gradient function for a function. So we find the gradient of this curve at any point, and we can see that the gradient of the curve at the point where it reaches its maximum value will be 0. So the A is in the place of what we normally have y. So we're going to find the differential of the function that is named A with respect to x. We're going to find dA dx. When we differentiate this, it gives us the gradient function. So if you differentiate 48x, the x is dropped. So you got 48. Okay, went to the x term. All right. When you differentiate 10x squared, you multiply by the power, so you get minus 20 times x to the power of 1. Okay, in fact, we did the same thing here really. This was to the power of 1, we multiplied 48 by 1, and then we took 1 from the power. X to the power of 0 is 1, so we're left with 48. That's the reason why it becomes 48. But you can think of it, the x term, the x is dropped. That's a bit of an easier way to think about it. Right, so we got 48 minus 20x. Now what we know, that the ADX is the gradient. So at the maximum point, the ADX is going to be equal to 0. Okay, the ADX is equal to 0. So if we take this expression, 48 minus 20x, and we equate it to 0, we'll find the x value at this point where the area is its maximum. So we're going to have 48 is equal to 20x, add 20x to both sides, and divide both sides by 20. We have 48 over 20 equals x. Now what goes into both of these? Well, 4 does. Okay, so x is therefore equal to 48 divided by 4 is 12 over 5. So we can say x is equal to 12 over 5. We can leave it like that if you want to, or we can say that's going to be 2.4 centimeters. So when x is 2.4 centimeters, we're going to have the maximum area. So we want to find that maximum area. So I'm now going to take that expression and replace the x with 2.4. Okay, I can do this. 2.4 minus 10 times 2.4 squared, and we can just use the calculator for that, no problem. So 48 times 2.4 minus 10 times 2.4, and the 2.4 is squared, and that gives us 288 over 5, or 57.6. That's centimeters squared. That's the maximum area. Okay, 57.6, or if we want it as a fraction, 288 over 5. Now that's one way of finding the maximum area. Okay, another way of finding the maximum area is to basically complete the square for this expression over here. So when we have a equals 48x minus 10x squared, if we complete the square for this expression, we will be able to work out what the maximum value of this expression is. Now to complete the square for this, it's a bit of a hassle. Okay, we have to first of all express it as 1x squared. So what we're going to do is we're going to take 10 out of this, and we'll have inside, that's going to be basically 4.8x minus x squared. Okay, and then we have to try to complete the square for this. In fact, what we'll do is we'll in fact take out minus 10 from here. So you have minus 10, and this will be x squared minus 4.8x. And when we complete the square, we've got to do the following. We have minus 10, and you're going to have x minus a half of this coefficient, which is 2.4 squared, minus, and because we have taken 10 out of the whole thing, okay, I'm going to have to have a bracket here for the whole thing. We're going to have minus the square of 2.4. So we're going to take 2.4 and we're going to square it. That gives us 144 over 25. Okay, I'll write it like that for now, no problem. 144 over 25. And then what I have to do is I have to multiply both of these by minus 10. So I have minus 10 times, I have x minus 2.4 squared, and here I'm going to have plus, and that's going to be 144 over 25, which is going to be times 10. If I multiply this by 10, that's going to give me 288 over 5. That's going to be 288 over 5, which is exactly the same as we got for our answer. So we say the area therefore is 288 over 5 minus 10 times x minus 2.4 squared. Now once I've completed the square, now I can see that when you complete the square we get the vertex. The vertex is the number inside the bracket that makes the bracket 0. So the x coordinate of the vertex is 2.4, and the y coordinate of the vertex is whatever's left outside the bracket, which is 288 over 5, which we mentioned is basically the same as 57.6. Okay, that was 57.6. That's what we got, right? 288 over 5 was what we got when we found the value of the maximum by differentiation. So we got 288 over 5. That's the vertex. So therefore we can say the maximum area is 288 over 5. 288 over 5, which is 57.6 centimeters squared. Okay, so there's two ways of doing this. One is by differentiation. Another way is by completing the square. I think the differentiation way is probably easier here, but there are alternative ways of doing this. I kind of like mix them up here, but anyway, that's how you deal with finding the maximum of you know, an expression. Okay, you find the maximum of the expression. Now, it didn't tell us to justify that it's a maximum. The fact that we've drawn this graph shows us, we've kind of shown that we understand it's a maximum, so that's fine. All right, so that's the answer to this question. Other questions from this particular paper can be found in the playlist, which will appear in the top right of the screen at the end of this video. Other questions dealing with applications of differentiation, okay, which is like finding maximums, minimums, and things like that, you can find in the playlist over here. You can subscribe to the channel by clicking on this link, and you can watch a video here which tells you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.